welcome back to Maths with Mitch. Today we're going to be looking at graphs of the trigonometric ratios. And we've got a picture of the unit circle up already because we're going to use this unit circle to help us draw these graphs. So let's get into it. So let's firstly look at cos or cosine, and we can graph that. So let's firstly start with some axes that we're going to draw. Now let's have a think about what we're actually going to be plotting here. We're going to be talking about the value that cosine changes as we go through an angle. So remembering we're measuring our angle from the x-axis and round in an anti-clockwise direction. And what we're actually going to be looking at plotting is the x-coordinate. So we can say actually the value of x, which we know is actually cos theta. So we're going to be graphing cos theta as we change the input angle theta. So if we mark some points on the graph, so let's do 90 degrees, 180, 270, 360. Now you might also be asked to do minus 90, minus 180, or in fact even further. And we'll talk about what it means to be negative in the angle. But firstly, let's do it in the positive direction. We'll plot these points. So we can say it's 0. So we have 0 angle. That is this point here. We can see the x-coordinate is 1. So we can plot 1. Now let's look at 90. This point here, the x-coordinate is 0. So we can draw that on our graph here. Next, let's look at 180. So we go right around the circle to 180. We're now at this point here where we know we are negative in the x direction and on the 0 line in terms of the y-axis. So we are negative 1. So we now at this point here. 270, we're at this point here, which again we haven't labelled up, but we are at 0 in the x direction and minus 1 in the y. So we are back at 0 in terms of the x coordinate. And at 360, we're back at the original start point. 360 is a full circle, so we can say we're back at 1. Now before we join the graph up, we are going to quickly think about what is minus 90 and what is minus 180. We've defined this as the positive direction of the angle, so it would make sense that the negative would be in the opposite direction. So if you were to go minus 90, you've actually traveled in this direction here. And that means you're back at this point on the circle, and we said the x-coordinate was 0. So we can plot this as 0. At minus 180, you're back at this point here, and we are on the x-coordinate at minus 1. Negative 180 and positive 180 are going to be in the same position. They are both directly the opposite side of the circle. So we can join these up. Remember that we're looking for a nice smooth curve, not to join it with straight lines like a dot to dot. Hopefully you've got a slightly smoother curve than I do, but it should look something like that. So what does that actually tell us? That tells us at any point on this graph, you could pick an angle theta, and you could read off a value for cosine at that angle. So let's say you were given the angle 60 degrees. You could read up to see what this value is here. You would read it off this axis. But we know what cos 60 is already. We said cos 60 was a half. So you would expect this to be a half here. And that's roughly on the graph. I mean, this is a very inaccurate graph, but that's effectively what this is showing. So for any angle, you can now see a corresponding value for cos theta. So you're plotting the entire range of cos across 360 degrees of a circle, plus beyond that in terms of the angle range, and it's a repeating repeating graph. So that represents cos. So now let's do sine. So we can do the same exercise and we'll get this. You can see the sinusoidal graph in the red here. So this time we've plotted the vertical coordinate. So you're plotting sine as you go through the angle. And you can see that it's a very similar shape. However, it's offset. And what we can say about that offset, if you were to put them next to each other, it is 90 degrees. So cosine and sine are at a 90 degrees phase shift. And that actually helps us think about the names and where the names come from. So sine is a sinusoidal graph. And this is something you'll see in a variety of other applications in physics, but it's a sinusoidal shape. And cosine gets its name because it's a complement of the sinusoidal wave. It's a phase shift, but the same graph. And that's where those names come from. So now let's look at tan. So tan's going to be different. We know that it represents geometrically a different thing. So we can look at that separately. So for tan, let's construct our axes again. I'm going to draw them slightly differently this time. We're going to draw some lines on to represent the 90, 180, 270, 360, and also minus 90. So we can just see where they line up with the graphs above. So let's label those up. Now again, we're going to be looking at angle phi, and we're going to be looking here at the value for tan. Okay, so now we said previously tan equals opposite over adjacent, which is sine over cosine. So we can use that now to think about some of the points. So let's look at 0. So when we're at point 0, we can look at the graphs above. We have sine equals 0. So at 0 degrees, sine equals 0, cos equals 1. So tan is going to equal 0 over 1. Now if you have 0, we just know it's the point 0. It doesn't matter what you divide it by, it's always 0. So we know it's there. Okay, so now 90 degrees. Sine theta is 1. Cos theta is this time 0. So now that gives us tan is 1 over 0. Now when you divide by 0, you're going to get an infinite number. 0 goes into 1 as many times as you can possibly think it does. So that's going to go off effectively to infinity, like this. So next, rather than jumping ahead to 180 degrees, we're going to look at what happens at negative 90. So negative 90 degrees, we have sine theta equals minus 1, and cos theta equals 0 again. So that means tan theta is going to equal negative 1 over 0. So again, we're dividing by 0. We know the graph's going to go off to infinity. But this time we've got a negative 1. So it's negative infinity. So we know the graph is going to go off in this direction. And that gives us the shape of tan from negative 90 to positive 90. Now another thing we can think about in terms of whether this is positive or negative, where this is going to be, is the quadrants. We said from 0 to 90, tan is going to be positive. We also said in this quadrant here, between 270 and 360, but again, that is the same as 0 and negative 90, we said tan was negative. So we can check our graph, and that's correct. We can see that it's positive here, and it's negative here. So we've proved on the unit circle if it's positive or negative, and then we've shown on the graph that that's correct in terms of what we expect it to look like. So now let's move on and let's look beyond that. So we've already done it at 90, and we know it's infinity. So it's infinity at the point 90, but it never reaches there. So really when we're drawing this, we're saying this goes up to a vertical line at 90 essentially, but never quite reaches there. So if we look at 180, so we can say sine is 0, cos is -1. So that gives us -1 over 0 again. That gives us 0 over -1. 0 divided by anything is 0. So we know that's 0 at that point there. So again, we're going to be crossing through the x-axis in this graph. So now let's look back to the 90 degrees. Now we've already worked out at exactly 90 degrees, it's 10 towards infinity, but now we need to think what we can do is look just past 90 degrees. So let's think about 91 degrees. But we can still use the graph of sine above. So here, 91 degrees, it'll be just short of 1. So this isn't accurate, this is just thinking about it from the graph. And here we can say cosine at 91 is going to be just below the x-axis, but it's going to be something small. And now we can use those. So if we were to take those out, we can say tan, this is at 90 point something or 91-ish, just past 90 essentially is what we're seeing here, is sine over cos. So we now have 0.99 something divided by a very small number, essentially, in the negative. And the key thing here is if we divide by a very small number, we end up with a very big number. And we've already said at 90 degrees it tends towards infinity. And so infinity, it's going on forever. And at this point here at 91-ish degrees, or just past 90 degrees, it's going to be a very large number indeed. But we do have the negative sign, so we know it's in the negative direction. So we can say that it's coming from a very large number in the negative direction. We know it's infinity at 90 degrees itself, so we can plot that again. Now, again, use the unit circle. It tells us what direction that line is, because we've said between 90 and 180 degrees back at the unit circle here, tan is negative. So we know that tan is negative here. It is below the x-axis. And we can then look at it, the unit circle, we know it's going to be positive here. So we know it's going to be up in this area here. And we can look at 270. So at 270, we have sine is -1, cos is 0. So we have -1 over 0. And again, that's infinity. It's negative infinity. It's negative infinity, but infinity by its definition is all numbers, all encompassing. And what we can do is again the same exercise, which infinity is a straight line. Therefore, it's going to tend towards a straight line. We just need to know in which direction it's tending towards a straight line. We've already said the unit circle says it's positive in this side. And we can do the same exercise. So look at 269. So for 269, we have sine is just shy of -1. So it's going to be minus 0.99999 something. And here for cosine, we have minus 0.000 something something something. So we can say tan is going to be equal to negative 0.99, a large number in this context, over cosine, a very small number, but negative. No. So we know a negative and a negative divided by one another gives a positive. And again, we're in the same circumstance, that's going to give a very large number. 0.999 divided by a very small number, 0.000, gives a very large number. So the value for tan is going to be coming down from infinity back down to 0 here. And what we start to see is that this is a repeated shape in the graph, and we can prove that that repeats every 180 degrees if we were to continue, and you would keep getting the same shapes of the graph for tan. But what you can definitely see is that we are negative here, positive here, negative here, positive here, and that keeps repeating, and that reflects what we've proven with negatives and positives around the unit circle. So there we are. You can now graph cosine, sine, and tan. So all the trig ratios graphing across from minus 180 through to 360 in repeating patterns, and you can use them to then find values for the ratios. Now, please do in the comments if there's anything that isn't straightforward, you don't understand, or if I indeed haven't explained very well, then please leave a comment, subscribe to the channel if you want to see more, and press the bell icon. Thanks for watching.